You're standing in your kitchen, peeling a banana. Maybe it's breakfast, maybe it's a snack you grabbed on the way out the door. You eat it, the way you've eaten 1,000 bananas before, without a single thought in your head about physics. And yet, in that exact moment, something is happening inside that banana that most people would find genuinely unsettling if they actually understood it. It is emitting radiation, right now, in your hand. Before you even take a bite, and before you panic and throw it in the bin, here's the reversal. No, this doesn't mean bananas are secretly dangerous, and no, you are not being poisoned every time you have a smoothie. But the reason people say bananas are radioactive as a throwaway joke, and the reason that joke is actually built on real, measurable physics, is way more interesting than the meme version. Because once you understand why a banana is radioactive, you'll realize the real story isn't about bananas at all. It's about you. You are radioactive too. You've been radioactive since before you were born, and you will be radioactive until the day you die. This is the story of a number called the millisievert, a banana-shaped unit of measurement that scientists genuinely use, and why the thing that makes bananas glow ever so faintly on a Geiger counter is the exact same thing keeping your heart beating on schedule. First, let's clear something up, because most people get the mechanism completely wrong. They assume radioactive means something artificial, something contaminated, something that leaked out of a reactor and ended up in the food supply. That's not what's happening here. This isn't pollution. This is potassium. Bananas are extremely high in potassium, which is exactly why every health class and every nutrition label points to them as the poster fruit for the mineral. Potassium is essential. Your nerves cannot fire without it. Your heart cannot beat without it. Every single cell in your body is constantly shuffling potassium in and out of itself just to stay alive. But here's the part nobody mentions in health class. A small, fixed fraction of all the potassium that exists in the universe, roughly 1 in every 8,600 atoms, is not the stable, ordinary version of the element. It's an isotope. And isotopes are where this whole story actually begins. To understand what an isotope is, forget the periodic table for a second, and think of it like this. Every element is defined by how many protons sit in its nucleus. Potassium always has 19 protons, no exceptions. That's what makes it potassium. But the number of neutrons sitting alongside those protons can vary. Most potassium atoms carry 20 neutrons, and that version is completely stable. It will sit there forever, doing nothing dramatic, for the entire lifespan of the universe. But a small number of potassium atoms carry 21 neutrons instead. And that extra neutron makes the nucleus unstable, like adding one too many people onto a seesaw. Eventually, without warning, without any external trigger, the nucleus rearranges itself to become more stable. It ejects a particle, releases a burst of energy, and transforms into a different element entirely. That process, an atom spontaneously breaking down and releasing energy, has a name you've definitely heard before, even if nobody ever explained what it actually meant. It's called radioactive decay, and the specific unstable version of potassium responsible for it has a name too, potassium-40. So here's the reveal. Bananas are radioactive not because of anything sinister, but because they are packed with potassium, and a tiny, constant, predictable fraction of that potassium is potassium-40, quietly decaying, atom by atom, releasing small bursts of radiation as it goes. It's not a contamination. It's not a defect. It is a completely normal, unavoidable feature of an element your body cannot live without. Here's the number that makes this concrete. A single banana emits an amount of radiation equal to roughly 0.1 microsieverts. That is such a tiny amount that scientists studying radiation exposure actually invented a semi-joking but genuinely used unit called the banana equivalent dose, or BED, specifically to help explain radiation exposure to the public in terms people can intuitively grasp. 1 BED equals the radiation from eating one banana, and once you have that number, the rest of the world suddenly makes a lot more sense. A chest X-ray is roughly 200 bananas. A round-trip transatlantic flight, thanks to increased cosmic radiation exposure at altitude, is somewhere around 400 bananas. Living within 50 miles of a coal power plant for a year, because coal contains trace radioactive materials that get released when burned, exposes you to more radiation annually than living next to a nuclear plant does. Context changes everything, and the banana, ridiculous as it sounds, became the yardstick scientists used to put all of it in perspective. But here's where the story gets genuinely strange, and this is the part almost nobody knows. You don't just eat radiation when you eat a banana, you already are radiation. Your body, right now, sitting there reading this, contains roughly 140 grams of potassium at any given time, spread through your muscles, your blood, your nerve cells. And that same 1 in 8,600 ratio applies to you exactly as it applies to the banana, which means inside your body, right now, roughly 4,000 atoms of potassium-40 are decaying every single second, not once in a while, every second, for your entire life, since before you were born. Your own body has been a low-level radioactive source. You are, biologically and literally, quietly glowing. This is called internal radiation, and it's not unique to potassium. Carbon-14, a radioactive isotope of ordinary carbon that's in every carbon-based thing that has ever lived, is doing the same thing inside you right now too. You are not eating your way into radioactivity by having a banana. You were already there. And this is the layered reveal, because it turns out this isn't a story about one weird fruit. It's a story about a background hum of radioactivity that runs through the entire natural world, stacked from multiple independent sources at once. There's the potassium-40 inside your own cells. There's cosmic radiation raining down from space, filtered but not entirely blocked by the atmosphere, more intense the higher up you go. There's radon gas, a naturally decaying radioactive element that seeps up out of the ground in nearly every basement on Earth. There's trace uranium and thorium sitting in ordinary rock and soil, in granite countertops, in the bricks of certain buildings. None of this is contamination. None of this is a leak or an accident. This is simply what the universe is made of, a background hum of decay so constant and so ordinary that your body evolved inside it, alongside it, and depends on some of the very elements causing it. Here's the twist that complicates the harmless banana takeaway, just enough to make it interesting rather than tidy. Your body doesn't just tolerate this background radiation, it actively regulates it. Potassium levels in your bloodstream are kept within an extremely narrow range by your kidneys, because too much potassium, radioactive or not, is genuinely dangerous to your heart rhythm. If you ate an enormous, physically implausible number of bananas at once, somewhere in the range of 300 to 400 in a short window, the potassium itself would kill you through cardiac arrhythmia long before the radiation became a meaningful concern. In other words, the radioactivity of bananas was never actually the threat anyone should be worried about, but that doesn't mean bananas are infinitely, consequence-free safe either. It's just that the danger and the radiation are two completely separate conversations that happen to be wearing the same fruit as a costume. The reason none of this ever adds up to actual harm for a normal person eating a normal number of bananas comes down to one more overlooked mechanism. Your body isn't just tolerating this radiation passively, it's replacing itself. The potassium in your cells isn't a fixed, permanent stockpile sitting there accumulating decay events forever. It's constantly cycling in and out, replaced through your diet and flushed out through your kidneys, on a rotation of days, not years. The potassium-40 atom that decays inside one of your muscle cells today is very likely to be excreted and replaced with fresh potassium from your next meal before it can do anything meaningful. Your biology isn't fighting the radiation, it's simply cycling faster than the radiation can accumulate any consequence. Stack that turnover on top of the vanishingly small dose per atom, on top of your kidney's tight regulation of potassium levels, and you get the full picture. Not one single reason bananas are harmless, but 3 or 4 independent, boring, extremely effective systems, all quietly working in the background, none of them designed specifically to protect you from radiation, all of them doing exactly that anyway. So the next time you're standing in your kitchen peeling a banana, you can go ahead and remember all of this, or you can just eat it, because honestly, both are correct responses. That banana in your hand really is emitting radiation, in a way that is completely real, scientifically measurable, and used as an actual reference unit by actual scientists. But so is your hand holding it, so is your heart, so is every muscle that moved to bring it to your mouth. The banana was never the anomaly. It was just the one thing in the room quiet enough, and famous enough, and yellow enough for someone to finally notice. Turns out the most interesting things are hiding in plain sight. Subscribe so you don't miss the next one.